Well, Mr. Stoyanov, tell us about Aptica. And I know you're a think tank, right? So what are you thinking, and what are some of the opinions you can share with our attendees today?
Firstly, ni hao. So what's I suppose unique about Aptica is the fact that I myself, the founder, have a background in quantum physics. And so we came very quickly to the realization that a lot of business innovation challenges that are being faced around the planet are far removed from business and instead can be perhaps better approached using scientific methods. And so Aptica really, as an entity, takes user-centered or human-centered design and combines that with scientific thinking to solve some of the complex business challenges that we're facing, specifically in innovation. And rather than talking about how we do it, I'd like to talk about one particular interesting use case where we put the person at the center, where we're working out of the United Arab Emirates. And there's one case in Abu Dhabi that we're very excited about. We're working with the government and in fact across both the public and the private sector. And what we're looking at is the journey of a person before even deciding to come to the largest emirate in the United Arab Emirates of Abu Dhabi. And imagine that we're looking at capturing data and then using artificial intelligence to understand, before a person even makes the decision to visit the country, how they come about with that decision. We follow that person using their data in a seamless way. We follow them by the time they make a flight booking, all the way through until they finally come and land. The experience that they have as they move through the airports and into the city itself. And then we track them in a way that we can understand the behavior as they're moving through the city, and then all the way back until they land back into the airport and back in, and when they finally tell their friends about the experience that they've had. So we look at this very much as a seamless experience driven at the end by the user. So rather than looking at the technology and the solution, we're instead deeply focused at looking at the user and looking at the problem that we're trying to solve. And I'll add that Einstein was asked once if he was given 1 hour to solve a very difficult challenge, how he would spend his time. And Einstein was said to have mentioned, I would spend the first 55 minutes trying to work out the problem. And once I understood the problem deeply, then I would spend the last 5 minutes coming up with a solution. So that's something that we're very much motivated by.
At the same time, when they are amazed by this technology, there's this, it can be a human voice, but it's taking appointments and reservations for the restaurants. But at the same time, people feel a little bit uneasy when they realize what had been serving them was a machine. So, are you worried about these things?
Like I'll be the resident contrarian here. If we look at a very recent case that happened in March or April of 2017, unfortunately the discussion that we're having at the moment is about this, I perhaps am at fault for opening up this idea of superintelligence. But in fact the reality is that the intelligence only has to be good enough. And in fact the real disruption happens in the case that I wanted to briefly share. JP Morgan, a large investment bank, had an issue. They do a lot of what's called high-frequency trading, and they have a team of contract lawyers on their books. And what these people do are very basic types of legal work. And what they do is, we call it in English, dotting the I's and crossing the T's, the type of work that's very repetitive, relatively simple, and requires quite a bit of effort to do, but is simple in nature. So what JP Morgan did was actually hired a team of computer scientists, non-experts, non-subject matter experts, it should be mentioned in contract law. And what they did was took the contracts from the contract lawyers and took them before the contract lawyers amended them and then afterwards, and then fed them into a machine learning algorithm. And they did that repeatedly, and then they finally took the ones that the computers were doing and compared them with those results and fed them in as well. This is called primary and secondary machine learning. And what they did at the end was made a comparison where they took the number of documents that the entire team would have completed over 360,000 hours, and they fed that amount of documents to the algorithm. Does anyone want to have a guess at how long it took for the algorithm to calculate or to make those documents? Anyone want to have a guess? It took the algorithm 2.85 seconds to replicate the human effort of 360,000 hours. And so when we look at these changes that are happening, in my view, this is not blue-collar work. This is not sweeping streets or doing this kind of thing. These are people with very high-level degrees who've gone to university for a very long time, and also, it should be noted, who have summed quite a large amount of money in student debts. And very, very quickly, there was an algorithm that was created by non-subject matter experts that was able not to copy but to replicate their efforts. And so for me, I think what's really interesting is not when the algorithms are going to be able to beat humans at chess or at alpha or any of those things. It's when they're going to be good enough to be able to displace what is currently seen to be human effort. And so the most exciting thing will be in white-collar work.